The Allegheny College Computer Science Department welcomes you to the panel event Computing with Care, a look into how researchers develop an ethical awareness of the issues inherent in a CS research process. This event is part of a series of efforts funded in large part by a grant from the Mozilla Foundation. Broadly, concepts pertaining to ethics seek to define the myriad ways that participants in a social system accommodate and understand the conflicts between practices and values in that system. While the discipline of computer science has not widely been classed among those disciplines with significant pressures and debts owed to ethics, recent calls, including that from a recent report by the National Academies, assert that few, if any, technologies are purely value neutral. Further highlighted by the work of scholars such as Safia Noble and Kathy O'Neill, there exists an increasingly common consciousness around the ways in which personal and community values, assumptions, and biases become deeply embedded in technical systems. As you might have noticed, none of these forces are purely or at all technical. Much of the work done to design systems still rests in the hands of the human designer. Our goal in this panel is to surface some of the interventions researchers can take to prevent or recognize when these forces appear in their or others' work. Following on the National Academy's report recommendation to take steps earlier in a research process to address potential ethical concerns, this panel takes advantage of the close of another season of Senior Comprehensive Projects, the COMPS, to revisit lessons learned. Students and faculty will discuss their experience with specific challenges taken from their research. In specific, today's panel participants are on the faculty side, Dr. Oliver Bonham-Carter, Dr. Gregory Kaphammer, Dr. Janil Jumadinova, Professor Douglas Lumen, and on the student side, Catherine Leyenmark, Tyler Pham, Megan Munzik, Teona Bagashvili, and Noor Bucci. Let's get to the panel. We're going to get started thinking about the group together, Catherine Leyenmark, Janil Jumadinova, Tyler, and Oliver Bonham-Carter, thinking about predictive data analysis and how bias and privacy concerns factor into that.
Hello, everyone. Data analysis, specifically predictive modeling using machine learning, may lead to different biases and privacy issues. This is what we would like to highlight in this section of the panel. In my most recent project, I built a predictive model using a combination of machine learning algorithms that can automatically extract and summarize information for decision-making using textual and raw sensor data that comes from the sensors placed in environmental situations to be used in environmental monitoring applications. Now, it is commonly known by now that machine learning algorithms are susceptible to algorithmic bias, which essentially refers to systematic and repeatable errors that can create unfair outcomes. For example, privileging one arbitrary group of individuals over the others. It's also known that bias in algorithms can stem from unrepresentative or insufficient training data, or the reliance on flawed information that can reflect historical inequalities. That's why it's really important to use testing to identify problems and potential bias early on. In this project, through specific word tagging, testing, and analysis by a third party not involved in a research project, we determined that one of the data sets that we collected from the sensors to be used in our machine learning algorithm was actually incomplete. In this project, we had to return to data gathering phase of the project to ensure that the information gained by our model was representative, because it was to be used for policy making in various applications later on. So what I learned in this project is that despite what application you are targeting with your machine learning algorithm, we need to really carefully assess the bias from an potentially incomplete data.
So up next we have Catherine.
So my project was on data-driven buyer persona creation, and if you aren't familiar with the marketing term of buyer persona, it's basically just a semi-fictitious representation of a intended customer, like a target base or who you want to sell or market your products to. My project was about discovering patterns in consumer consumption behavior. So basically, I worked a lot with human demographic data as well as behavioral data. And there's a lot of issues that can come from that, a lot of ethical concerns, but the biggest were having a cognitive and implicit bias. Basically, with an implicit bias, you already have stereotypes in your head. You already think how people are going to act. And you already have those personal experiences that you've gone through with people. So you might already have a bias in you that you're saying, oh, this type of people is going to want this type of product marketed towards them. But you have to take into account that bias. You have to take into account a cognitive bias and know that sometimes the data is going to show you something completely different than what you thought. And you have to be able, as a data analyst, to take into consideration that maybe what you thought was going to happen is not what's going to be the results. So that was something that I had to really focus on within my project in the data analytics that I was doing. Just because I needed to be aware that I was going to find correlations, not causations in data, just because it's so hard to do so within human-based data. So those were kind of the two biggest ethical concerns that I had, and it's something that needs to be made aware of in any data analytics project.
Tyler, you're up next.
So for my senior project, I decided to look into the Bitcoin price prediction. In order to do this, I utilized machine learning and sentiment analysis. To predict the price of Bitcoin specifically, I collected Twitter tweets, which then served as an input into the sentiment analysis model. And then based on the ratings that were generated, it would then go into the machine learning algorithm in addition to historical Bitcoin price data, which would then give the model predictive power and predict the price of Bitcoin 4 days into the future. Based on these two approaches, I was able to get the overall trends of Bitcoin's price. However, each day was a bit off. Aside from that, there were several ethical issues that arise that I have learned when working on this project. One of which is collecting private data that people are using on Twitter. Essentially, what I've learned was to just follow the guidelines that Twitter has in place so you do not overreach or overextend into certain personal data that could be harmful if it gets into the wrong hands. The other part of the ethics that I've learned was that there is personal and sensitive information on Twitter. Essentially, Twitter is a public database with not only Twitter tweets, but a lot of personal information when people sign up to make their accounts. And if the data gets into the wrong person's hand, for instance, an attacker, potential data threats could be occurred. So my main takeaway from this project is understanding that you have to be cautious and wary of how you collect and store data so that it does not get into a potential attacker's hands that they could then use in future attacks, which could then lead to problems on my part as a researcher and most importantly, the users of the Twitter account.
And hopefully folks at home are taking down questions you can ask later. Once we get to the end of the panel, we'll take those in chat. So be sure you're paying attention to not only the individual speakers and what they're talking about, but also think about those questions that are coming up for you in terms of topics that they may be bringing up. So we're going to move on to the last of this unit. So all these are scheduled sort of in units. The last of this unit is Oliver Bonham-Carter.
All right. Hello, everybody. So one of the directions in my own research is in bioinformatics. And so bioinformatics is the marriage of biology, mathematics, and computer science. And one of my research projects that I'm working on right now is the study of gene expressions. Now, gene expressions are kind of like the degrees of how much a gene is putting out or is producing certain types of proteins. And we care about this because in certain types of diseases, there are certain genes that are putting out more proteins than others, and those proteins might somehow make up the disease. So for instance, in cancer onset, for instance, there are certain genes that might be producing a whole bunch of protein, which they shouldn't be. I mean, that's really what cancer is, like kind of the nonstop production of certain proteins. And so it's not just one gene, though, that does this. We're thinking that there are several genes that somehow work in tandem. So for instance, you have one gene that maybe starts the mess, but then you have another gene which is somehow guilty by association. And so I'm using different types of correlation studies and mathematical models to try and find these correlations between the responsible genes, or genes that we think are responsible for the onset of those diseases, and other genes which may contribute to the onset of those diseases. So the ethical conundrum in this work, though, is that the data for this work must come from actual patients, people who are actually diagnosed with a disease, maybe people whose insurance companies haven't been completely told that they have this disease, or maybe they haven't told their families or whatever it may be, but they actually do have the disease. And so maybe they don't want their name out there. Maybe they don't want they're concerned about privacy. And so what I do though is I use the data that I have actually comes from what's called the Genomic Data Commons Data Portal, and I have to trust that the data that they use has actually been anonymized. That means that the names of the patients and the information about the patients, anything that you could use to somehow distinguish one person from another, according to this data, has been removed. And so I have to trust that that's happening. But also, though, I have to be aware that, for instance, even though this data has been anonymized, anybody with information about certain people who went to a hospital at a particular time, who had a certain type of test during that same week, maybe could perhaps be the patients who are on my data, or the patients that are in my data. So in other words, knowing that somebody was actually present when that data was being taken could be enough information to say, yeah, it's this person and not that person. And so that is what I call dangerous metadata. And so what I try and do in my own research is that I only publish, for instance, data which really cannot come from any particular person. I only cover basically the correlations. So the data that I'm using actually cannot, no matter what you do with it, you cannot wrangle it any further to extract any information about a person from that information. So on my end, I am upholding the privacy of that patient as best as I possibly can. And in spite of all the efforts, for instance, that may have gone into making the data anonymized, if there were some kind of a breach in the medical records department of some of the hospitals where the patients may have had their data taken, or they may have gone for treatment or something, if there was some kind of breach where somebody was able to find out that, yes, this particular person was in this hospital at this particular time, so therefore this data must have come from them, they would not be able to use that information with my publications to determine any kind of distinguishing features of the patients, because I only use the correlation information. In other words, I don't use any information about a person. And so I'm always very careful about making sure that I'm not using any information which could be used to identify people. And it is part of my responsibility to protect the identities of these people, because I'm a researcher and it's their right for privacy. And so I have to do whatever I can do to make sure that I maintain that right as far as I can do.
So we're moving from the ideas of how data sort of encodes biases, or how it can implicitly influence the ways in which we perceive or understand data, into a section which thinks about like where we get that data, which is kind of related. I think you heard a lot in that last section about those questions, and thinking about how we get our data and how we use that data then to understand better like what biases are encoded in there, or how does using such data actually further the hidden biases or problems with data sets that may influence results. So next up, we have Megan Munzik talking about their data set in swim statistics.
So my project was I created a data set on swimmers of Allegheny College, and with that data set, I tagged and counted those videos. So with my data set, there was a lack of diversity and gender bias within it. As you can see, there's two graphs on the screen. One's just of Division III athletes, and then one's of the sport of swimming. And as you can see, it's mostly the race of white people. So this was a lack of diversity within swimming as a whole, and also it affected my data.
So what responsibility do we have to actually collect representative data? And fact bonus for this, I have some bonuses in my section. The number of dogs we can fit on a paddleboard, 31, swimming fact. But the question about like what responsibility do we have to actually collect representative data, especially when, Megan, for the survey on the left, nearly 40% of folks didn't respond to the question. How does that kind of change the way in which the data can be interpreted?
I think that changes the data because we want to have a full representation of all diversity and gender.
So talk a little bit more about like how this data set plays into, well, when you're actually tagging it, how the statistics we saw on the previous screen influence what we see on the current screen in front of us.
So with tagging, as you can see, I have stroke and rest. Stroke being when the swimmer is most extended out of the water, and rest being when the swimmer is not extended any body part out of the water. And with this, we want to, so tagging the data, we did not have a full range of all the backgrounds of diversity and gender. With gender, it didn't really matter of the swimmer because it was mostly based on what the swimmer was doing in the water, but we just want to make sure that we still have it's trained on a wide range of diversity as well.
And maybe moving in a bit of a different direction, thinking about the ways in which data and our relationship to it ultimately changes how it gets understood or how power relationships can shape someone using data. The work that I do is, at least the one that I've pictured on the slide, is artistic work. So this is a book of poems that actually takes as its source an Italian architectural journal that really thought a lot about the ways in which design constituted a kind of very fierce political battle. Now, this was during the mid-century, so we're talking 40s to 60s, really 40s to 50s, when the Mussolini regime was in power and fascism was a large constituent of European central politics. So in using this data set, we're thinking about mistranslating words that I do not understand, that I don't choose to understand because I find the ideas objectionable, and somehow trying to use those as material, still respecting the fact that I'm not an architect, I don't speak Italian, I certainly was not necessarily alive during the time that this was generated or created, so I'm working with data that goes beyond me in a lot of different ways. So in mistranslating data or mistranslating language, this is sort of one example of how it can go. So if we look at the Italian, you have buonanotte, which is just good night, I guess. I don't really understand Italian all that well. But when you hear it and you're trying to process it and translate it in ways that you don't quite understand the underlying text, you could come out with something like bones or naughty, which is the kind of approach that I used on creating this text. This creates a lot of big questions around largely the ways in which my subject position. So this idea that I have a position to the data itself, and that position influences how people see the work that I've created. Do I have the ability to use this data set? Do I have the ability to speak through this data set? And fun fact, I still don't understand the original text. So I also did this on a German building text from the period, and I did it on all the issues of this one given magazine. And it does raise a lot of questions in terms of who am I, and who am I to step in this conversation in this way, and to take these words and use them in a way that misconstrues them on purpose. So a lot of these questions that you're seeing today on our presentations aren't necessarily answerable, which thinks a lot about how we as researchers, or we as artists, or as developers have to grapple with these and in some sense come up with our own answers, but come up with answers that we can feel confident we can represent to others. So in our last group, we have thinking about the ways in which developers can then put some of these to work directly, and thinking about Professor Kaphammer's group of Teona Noor and Professor Kaphammer of the ways in which engineering tools can create dependency for use.
So I've been working on a project which is about automatically checking the Git commit message. Git has been actively used by the developers to collaborate on software, and usually when they make changes to the software, they describe what was changed, why changes were necessary using the commit message. So it's a really good way to communicate with the other developers what the high-level ideas are behind the changes. However, oftentimes in practice, the commit messages might be neglected or completely omitted. So this tool that I've been working on will help the developers to automatically check the style of their Git commit messages. Some of the rules could be to check the length of the commit message, if commit message is capitalized, if there's a blank line between the subject and the body of the commit message, and so on. And as I've been working on this project, I've realized some of the issues that might arise. One of which is that, for example, if I'm designing this tool and I'm adding my own rules, somebody might be using this tool for checking their commit messages, and they might have preferences for different kind of commit messages. One of the ways I addressed this issue was to use the plugin-based system, meaning that the user will be able to add their own rules if they would like to. But even then, even if the user can also add their own rules, there's another issue. We may not be able to always cover every possible rule, right? That means that these rules are still defined by the human, and they check the style of the commit message, but we still don't know if the developer wrote descriptive commit message. So it's important for the user to be aware that just because their commit message meets all the checks, it may not mean that their commit message is descriptive of the changes. So it's important to keep those issues in mind as we use this tool for checking the commit messages.
My project, I was developing a tool that can automatically find bugs in our code base. And to do that, it uses test cases and a lot of the unit tests that the developers have wrote. And it's somewhat encouraging for developers to adopt test-driven development to use this tool, because it allows them more access to it and gives them more accurate data. And generally, the tool works by collecting two kinds of statistical information about the test cases and the code base. So mainly, which tests are passing or failing, and this is kind of referred to here on the slide as a test case status, and as well as the concept of test coverage, which is which lines of code do each individual tests cover from the code base. And by combining these two, we can plug the values into some statistical equations that generate scores that we can rank, and they would tell us which lines of code are more likely to contain our bugs. And this is from the concept that, let's say, a line of code that is ran by the most failing test cases is the most likely line to be faulty. And while this works most of the time, or with very decent accuracy, sometimes it fails and does not give the developer an accurate ranking that they should look for. So this brings up the question of when should the developer use it and when should they not, and how dependent they should become on it. And this is one of the ethical problems here, because if the developers become too dependent on the tool to find their bugs, then they'd be not very skilled at debugging their code without the tool. Specifically, this tool works for certain types of projects and might not work for others. So as developers move up and learn new skills and adopt new tech and tools, the tool might become less accurate, and then they would not have the skills needed to debug their code.
Hi, everyone. My name is Gregory Kaphamer, and I'm going to present some work that I've done in conjunction with my colleagues at the University of Sheffield in the UK and Carnegie Mellon University in the United States. We're focusing on something that is called a flaky test. Flaky test cases are test cases that sometimes pass or fail even when you don't make changes to the code base, like in the source code of the program or in the source code of a test suite. Flaky test cases are a serious problem for people in industry because they lead us to waste time. Those flaky test cases can be misleading, and if a flaky test case is passing when it should be failing, that might help us to inadvertently think the program is better than it actually is. So what we set out to do was to use a machine learning technique in order to automatically find flaky test cases. Like the tool that Noor presented, our technique requires test case status information. This test case status information records details about which test cases are passing and failing and how frequently they pass and fail. We also extract test coverage information, which tells us things about which lines of code in the program under test are being tested by the test cases when they're run. Finally, we extract a wide variety of test features. This might include how test cases access the file system, how much memory test cases allocate, or things about the complexity of the test cases themselves. Again, it's important to underscore that there's a tool that can automatically extract test case status, test coverage, and test feature information. We take all of that information and input it into a machine learning system that's part of a tool that can automatically predict test flakiness. The benefit of using a tool of this nature is that now developers are no longer required to keep an eye out for which test cases are flaky and to be diligent about ensuring that they don't introduce flakiness into their own test suites. So in some ways, that's really great because it has alleviated a burden on the point of the developers. The downside, of course, is that we may come into a situation where software engineers become overly dependent on our tool, and then they become less good at detecting flaky test cases on their own. This could especially be a problem if those developers start to work on a new project for which our tool is not yet designed to work effectively. Again, overall, you've seen from the work that Tiona and Noor and I have presented that while it's great to have software engineering tools that automate certain approaches, there's always the challenge of developers becoming overly dependent on these tools as an unintended consequences. At this point, let me turn it back over to our moderator for the next stage of our panel.
Thank you. So we've seen three different dimensions of how different groups in their comps and in their professional work have dealt with the topic of understanding, spotting, and being able to at least talk about or recognize ethical issues that arise in their work. And these were in the bias and privacy concerns area, responsible data sourcing, and unintended engineering consequences. So for folks that are here, feel free to post some questions in the chat. I will rephrase them to the panel so that we can answer them directly, and I'm monitoring the chat as well. While we're waiting for some questions to come in, I do have a question for the panel at large. In thinking about ways that you centralize like ethics in your practice, like these, all your projects are very specific, but we all work on a myriad of projects over time. Like, how do you keep ethics at front of mind whenever you're developing something or working on a project, so that you're sort of in the mindset to be able to spot these things and not necessarily fascinated with like what they call the awe of implementation or fascinated with the technical aspects of the stack? Like, how do you rise above those like nice, shiny computer science things and really make these central to your practice? I think I'll start with faculty if faculty have answers, and then we'll go down to the students.
I will just quickly share my perspective. And my perspective is, although it is very easy to get distracted by what brings us here to be a computer scientist, which is the building of the technology and creating of the technical solutions, I always think about the human, sort of the humans who are involved, whether those are the end users, the participants of the study, the individuals whose data was collected. And I think if you think about data as humans, or humans being involved in decision-making that evolves from predictive modeling, then it's a little easier to start thinking about implications.
The only point that I'll quickly share to address the moderator's question is that my group tries to focus on also doing user studies so that we actually have real software engineers using our tools so that we can actually gauge what are the unintended consequences. The other thing that we've really tried hard to begin doing now is to also conduct surveys of people in the industry to get a sense of the challenges that they're facing before we actually start building the tools. So I think from our perspective, it's really important to ensure that the people who are using our tools are central to the research process.
So there are some questions coming in, and the questions are actually mostly directed toward our student members. So I'll move directly to that. A listener, a watcher, asks for Tyler, do you think there are ethical concerns in the collections of users' public data, or is it only private data that could fall into the wrong hands? So how do you negotiate that line between the fact that you are allowed to get public data, but is that always okay just because it's public?
I would say although the data that is released on Twitter is public, it is aware by the users that they agreed to release this sort of data onto their database and platform. So it's really up to the user what they decide to release onto this specific platform. But in the case of my project, there wasn't really much private data that was collected because everything was on the front end related to the specific tweets that I've collected. In my specific case, I collected around 1,000 tweets each day for around 2 weeks. So there wasn't really much necessarily private data that was able to be collected in my specific project.
And I'm going to expand this to actually Megan. There's another question that has come in from the chat that I think thinks about public data sets in a similar way. Someone asks, you talked about data you gathered from Allegheny College sources. Can you talk a little bit about that process? Because your process was a little different than the standard Allegheny College data collection process, which folks who are going through junior seminar may know as IRB, the Institutional Review Board. Can you talk a little bit about the process that you went through to get that data and some of the issues that come out of how that all ended up?
Yeah, so first, I know there was Allegheny College swimming and diving footage on the athletic website, but I did not know if it was like public to use in a data set. So me and Professor Lumen contacted the IRB board and they said that all the videos were public. So I asked a person in the athletic department to have those videos. So they sent me over the videos and then I just was able to use those videos for my data set. But I just used the swimming and diving videos that were already public and already out there.
So a little bit different of a process. Traditionally, when you go through, just to get the back end of that question, when you go through the process, you need to go through IRB, go through a proposal process, and talk about the way your study is going to work. Megan's was kind of a surprise, simply because the athletics department essentially expects that every athlete surrenders a kind of right to privacy when they are when they're recorded on these videos, essentially. So they were just sort of given without that process for that reason. Now, is that right or is that not correct? I think is still an open question. So a lot of the questions you're going to get through today, they don't necessarily have right and wrong answers, or at different times the answers may be different, which is frustrating sometimes. But with this particular case, it was curious that it was just so readily available in that way. So to go back to questions coming from the chat, specifically for Dr. Bonham-Carter, someone in the chat is wondering if data was breached after a project or paper is already published, how is that handled? And would the project need to be redone, taken down, altered, disclaimed in any way? So how does that work if you have a data set that's breached in some case and your work is out there with it in it?
Well, that's a very good question. The thing is, though, that there are some types of breaches which happen, which take years to resolve, and that during that time you have to figure out, for instance, like who's liable for this, who's responsible for this breach. One thing I will talk about, though, is like, for instance, many of the before you can assign any blame, you have to figure out whether the people who are running this software that was designed to protect this data was actually updated and maintained so that the data actually would be protected as it should be. If it's found, for instance, that the data or the data was not protected because of bad security or there were patches that weren't put in place, then liability is then kind of, in some senses here, more understood. And so then those groups that are responsible for this data or the breach have to start paying some types of repercussions. But getting back to the original question, does the project have to be restarted? Well, I mean, sometimes, though, it's like the project has moved on and people cannot just, you cannot restart this project. And even if you had, maybe, for instance, there wouldn't be any draw to do that because maybe it's already, the premise that was trying to be studied has already been kind of ironed out in the paper. The more important thing, though, is protecting those patients, or maybe giving them some kind of forewarning or doing something to maybe compensate them for their data, which has been somehow breached. And well, like I was saying, sometimes it takes years to undo the damage which is done by these breaches. And so it's therefore very important that all types of security that we can use to protect data.
So I'm going to also pick one up out of the chat for Catherine, and maybe there are other folks that have thoughts on this as well. For working with data, especially thinking about consumer-driven data, how do you select or how do you find or source the most appropriate and reliable data for the analysis? Do you collect it? Was there data out there available to you? How did you go about putting together the material that really underpinned your project?
So I was fortunate enough to find an open source data set online. It's extremely hard to find kind of consumer data just because a lot of companies don't want to give that to other companies. But searching around, there are some sources that you can use for open source sets. And that's why it was a lot easier for me to run my project without having to go through the IRB, just because it was data that was already available and it was already anonymous data. So it didn't have any names associated with it. It just had basically demographics and how they behaved in the market. So that was pretty nice to use and it made it a lot easier. But again, it made it less accurate just because I didn't have those specifics. So I didn't have the exact company name that the data was coming from. I didn't have, again, any of the consumers. There was a lot of open-endedness to the data set that allowed my project to kind of remain unfinished. So it's a project that can look at the specific data set that I'm using, but it's not going to be always applicable to every other company data set that's going to happen. So that's the give and take of an open source data set. But yeah, if you look around, there are definitely some that you can use.
So from a question that's also in the chat, I'm going to kind of go toward the topic that I think Professor Kaphammer and Nora's presentations and Teodo's were dancing around a little bit. There are other tools out there that are newer or older. The one named in the chat is specifically GitHub Copilot, which for those folks that don't know about GitHub Copilot, for at least professors, it's going to be a conundrum in the near future. It does a lot. I'll leave it at that. You can go find videos. In fact, on Twitter, you can find people who write entire websites out of other people's code, and it's not about them at all. It's pretty funny. But talk a little bit about these tools that are a trade-off, right? So if we use them in the professional world, it's all about efficiency, or it's all about enhancing correctness, or it's about uniformity. But you're negotiating, or at least we're all in this educational space right now. So talk a little bit about how ethics differ between both of those spaces and how your work contemplates that as well, because you're kind of working for, as you gestured toward in your presentations, multiple audiences that can or cannot, should or should not use these tools for their ultimate ends because they end up shortcutting parts of process. So I think I'll throw it to Nora first, and then we can move over.
Yeah, I think that's the key thing here, is that we're talking about different audiences. And whenever we're looking at people that are working in industry, then their priority is to get the work done, to fix the bugs, to detect flaky tests, and do it as efficiently as possible. But whenever we're talking in an educational environment, that's not necessarily the goal all the time. I mean, while it's always nice to get the homework or the lab done as quickly as possible, the goal is to learn while we do it. And if there's some tool that can always find the bugs for me, or even write the code for me, if I only give it some hints through the comments, I might be getting the work done, but I'm not progressing with my knowledge about software engineering and computer science. So when I move on and go on to the workplace or research opportunities, I'm not as prepared because I didn't take the time to learn those skills. I instead use some sort of tool that's available to everybody and use that to do my work for me. And that gets really tricky whenever we're working with open source software, because it's accessible to everybody and it's documented and it's easy to use. So us as students, we kind of have to make sure that when we use tools, we're still learning and we're not, taking away from our experience. So yeah.
The quick additional point that I would share is that if you're in a professional setting, it's really important to remember that the GitHub Copilot tool is using a machine learning algorithm that is trained on all or almost all of the data on GitHub. So you, as a software engineer in industry, may not be legally allowed to use the code that GitHub Copilot suggests to you because it's under a license that actually would then be violated if you brought it into your commercial product. So I think as professionals who are working in industry, we have to be really careful about using a tool that automatically suggests and generates source code if it's suggesting it from a domain where all of the code is under an open source license.
So for the one final question, because we're getting sort of toward the end of time here, but I think this is an all-play question. I think everybody can talk a little bit about this one, is thinking about, we're all working with data. This whole panel has really been thinking about issues that crop up when we use data, because we've all done data-driven projects. Not every project is so data-driven, but I think all of our projects here they're basically dependent on having a lot of material to look at. In terms of choosing data sets, how do you assess the quality, the appropriateness, the fit, the usefulness? Because I know sometimes there are data sets out there that just are not in a format that's easily usable, but there's also data sets out there from years and years ago. I think I'll probably start to let some folks on the panel ruminate on that one because it's a big one. I think when I use data, I'm looking for very specific things. Like the data set that I choose to work on, to create work from, does something that no other data set does. So for example, the journals that I decided to take words from were a very specific, historically relevant, historically significant moment that work could only be done from that particular set. And I think in some other cases, you're going to hear things that are similar, but maybe mine is skewed more toward when I look for material, I'm not looking for material to prove for myself a hypothesis or to support the testing of a tool. I'm looking largely for what is in the data set that I can surface and only could pertain to that particular material. If you think about words like paint or colors or brushes or any kind of artistic implement, like certain artistic implements can only produce certain effects. And so you're looking at very specific data in order to surface a very specific outcome. Hopefully it happens, doesn't always happen. I've got tons and tons of projects where it just didn't go, but that's sort of how I'm doing it. I think I'll start going by talking to Professor Jumadenova to think about the fit, the appropriateness, the usefulness of a data set, and then I'll go through and everybody will wrap up.
Thank you. This is a great question. And for a researcher in the field who's primarily focused on the modeling and decision-making aspects that come out from using the data itself is less of an interesting perspective, I guess. And I had to learn over the years to go back and look at the data itself. So what I do is I usually go to the source of the data and I try to examine it, where it came from essentially, and if there is information about it. I think one of the challenging things that one of the other panelists mentioned was the difficulty of obtaining data. So sometimes we can't be too picky, and maybe that's an indication for a project not to go on. But what I do is I try to look at the source of the data and try to identify where it came from, how it was collected, to see if there could be some potential for bias. For example, if the data was collected through a survey, how was that collected? Could they be a response bias, for example, where only a small portion of population contributed to the survey? Or is there some sort of a selection bias when only, again, a specific part of the population was selected to generate the data, and how that could be affected? So the data at the source, the collection of the data, I think is a key for me, how it was collected and who was the participants of that collection. And the second thing is at the other end of the thing for me is when you, after you have used your model on the data, how do you interpret your results? I think it's really important not to take the results of your whatever predictive algorithm you're using at the face value, right? But to really investigate what it means and evaluate if there could be some potential conflicts there in the result side of things as well.
I think I'll open it up to Professor Bonham-Carter and then Professor Kaphammer, and then to our students to finish up the round.
What I'd like to say is, whenever thank you. What I'd like to say is, like, whenever I'm downloading my data, though, my data usually is bioinformatics, it tends to be from a biological origin. In other words, people. And so each data set that I use has a what's called a code book. And a code book is information kind of like what Dr. Janadinova was talking about, where it talks about, for instance, how the data was collected and how who the people were, who the participants were, all of those things. And so this is actually very important to have this code book, because I know, as a data scientist, I know that there are biases in any data which is collected by any person. It just happens that way. And so the code book helps me to try and find out where those biases are. And that helps me also to kind of frame my discussion of that data so that I'm aware that those biases exist, and I don't use those biases, or as far as I can tell, I don't use those biases in my actual research. And so the numbers that I'm getting out are as maybe, I guess they're as objective as possible, because I'm not using that, I'm not kind of using the bias that I perceive is in that data. But also another thing I'll say, though, is that when you are actually publishing with some kind of a data set, it's absolutely essential to say, to cite that data, to actually say where the data came from, when it was taken, and maybe discuss where it came from. Get to know this data. And also, when you actually kind of come up with your own results, it's very necessary to say, according to my data, this is the correlation that I found. But you always say, according to this data, because if you say, I think the correlation exists, then if there is a bias that other people know about, then people might say that, well, your research is no good because you are not aware that this bias is there, and therefore you're not a good researcher.
Professor Kaphammer.
And so you always want to say,
the point that I would share is that in software testing and software engineering research, you're building tools that are designed to make other people's software better. So you have to be able to conduct experiments to demonstrate that your tools are both efficient and effective. So the big question is, where do I get the subject programs that I'm going to use to show that my software engineering tool or testing tool is actually efficient and effective? And the short answer is, because open source software exists on GitHub, we primarily go to GitHub in order to get the subjects that we use in our experiments. And we know that we can legally and ethically use those software subjects because of the fact that they're released under an open source license. With that said, one issue that we have to think carefully about is ensuring that the programs we pick are representative in nature. That is, they have to be representative of the kinds of programs that people commonly implement. And we use a wide variety of metrics to help us to ensure that our programs come from different domains and have different levels of complexity and testedness. Those are the key points that I would share. Let me turn it back over to our moderator.
All right, so for students, I think we've talked a little bit about this in each of your presentations, but final thoughts on the sources of your data, how you used your data, where you found it, and other issues I think that might have come up. I think I'll start with Megan and go on down my screen, which is left to right, going to Tyler, Nora, and then Catherine. So we'll let Catherine have the last word. Megan, can you talk a little bit about your data set and some of the issues that came up that maybe were not so obvious that we've been talking about?
So first, I did not start with Allegheny data or Allegheny footage. I used just like YouTube videos of Olympic swimmers. And with that, I found that it was very hard because of like the video resolution, the video quality was all different. So it was very hard for like the model to recognize the swimmers. And another thing was there was different camera placements throughout like Olympic videos since it is televised. So once it like flipped back and forth through each camera, it was like hard to keep track of the swimmer. So I just didn't think that was like the right video quality and like resolution thing to use for my model so it can learn correctly. So that's why I moved to Allegheny College videos, which all had the same video resolution and image quality. So it was easier for the model to learn what the swimmers looked like.
So unlike most of the other projects, in my case, I had to actually construct my data set by collecting Twitter tweets. To do this, I use an API called TweetPy, which is in conjunction with Twitter database. And once I collected the tweets, it was rather difficult because there was a lot of extraneous information contained in the tweets, such as emojis, links, and other hyperlinks that could affect the sentiment analysis. So I had to conduct an extra step called pre-processing, which essentially cleans the data and removes
Nora, talk about your data set and how you
from the tweets to
understood
make
the
my
use in
sentiment
your
analysis
particular research
ratings more
application.
accurate.
So my search for a good data set that fits my project kind of relates back to the point that Dr. Kaffhammer brought up, which is finding a good source code sample to test my project on. And considering that my project was involving finding bugs in code, and it was mainly directed at beginner or novice developers, then we needed a code that is representative of what a beginner developer could write. So after looking through GitHub and kind of browsing some of the projects, we ended up using a like a tutorial or like an intro to programming algorithms repository. It was a collection of different algorithms that beginners learn when they're starting to program, and we decided that that is a good fit. Now there's many problems with just stating that this is an okay fit and displaying the metrics to make that clear. But I mean, it's not. It is very debated. So there could be argument about we should have used this to test our tool or a different repository. And even after we chose that, we had to filter it down to fit some restrictions regarding testing and how we can generate test cases for it. So there was many steps in testing our tool and picking our sample there.
Catherine, how did you go about finding the right data, knowing it was the right data, and handling issues around what was contained therein?
So kind of like Professor Lemon has said when he started this section of it, my biggest issue was that I wanted to do something that I didn't have the data for. So sometimes you have to realize, this is like, I guess, my final word for 580 students who are starting the research project. Sometimes the data controls your project, and that's okay. Sometimes you're going to have to modify what you want to do just because you do not have the resources to do it in this current time period, environment, whatever you have access to. And that's okay. You just have to make note of it in your project that this is what I can do to this extent with the data that I have. You might want to do grandeur things with what your project is, and you can note that in the future research section, or you can note that throughout your project. But you can also just be like, this is what I can do with what I have, and that is an okay way to go about your project.
And thank you for that final word that thinks a lot about our 580, our junior seminar course, whose projects are about to get underway next semester. They're about to go through the process that Tyler, Tiona, Megan, Noor, and Catherine all went through this year in using data or approaching programming projects that infringe on these topics we've been talking about today. So I'd like to thank everybody for participating. We had a very lively discussion and a wide variety of projects. Thank you for watching wherever you are watching from. We appreciate your time and attention today and look forward to seeing you at future streaming events.